Welcome back. So in this lesson, we get to cover one of the most important concepts in all of programming. And in fact, I might argue that it's actually the most important concept, which is conditionals. And the reason I say that conditionals are so important is that they are the one way that you add decisions to your code. It's how you add logic to your programming. So I'll give you a few examples of real-world uses for conditionals. Let's take an example of user login. So when you go to log in on a website, you type a password in that form, and there is code that checks that password that you typed in against the password in the database. And if they match, you log into the site and you get redirected to another page. And if they don't match, you usually get an error message of some sort. So there's two different paths given the same exact code. Another example would be when you buy something online, when you type in your credit card information. If it works, if the transaction goes through, you might get a confirmation email, you see a success screen, and if there's some problem with your information or you don't have funds in the account, you're going to get an error message. Again, two different outcomes. So now let's go see conditionals in action. So there are three key words that I need you to remember throughout this lecture, which are if, else if, and else. So these are the three JavaScript conditional keywords. And yes, I know else if is technically two English words, but to JavaScript, that is just one keyword. So the example that we're going to use to illustrate conditionals is that of a bouncer at a concert venue. So the idea is that we're going to have an age variable. And if a person is younger than 18, unfortunately, that person cannot get into our venue. If that person is older than 18, but they're not yet 21, that means that they can enter, but we have to draw an X in their arm or on their hand because they cannot drink. And then lastly, anyone else, if you're greater than 21, you can get in and drink. So those are the three things that we're going to try and write with code. So before we move on, we're going to do a quick recap of the Boolean logic operators from the last video. And the reason that we're doing that is that we actually use our three keywords that I mentioned at the beginning, if, else if, and else, in conjunction with these Boolean operators to make our decisions, to add the logic. So to recap, we've got less than, greater than, less than or equal to, greater than or equal to. Pop quiz here. What's the difference between these two? So pause your video and try and remind yourself the difference between triple equals and double equals. So the difference is that double equals performs type coercion, while triple equals is strict equals. So type coercion, let's start there. Double equals means that the number 1 is actually going to be equal to the string 1 when we use double equals, because JavaScript does not care about type. However, when we do triple equals, which is strict, it does care about type and value together. So 1 is triple equal to the number 1. But 1 would not be triple equal to the string 1. And then we've got these two operators, and or. And remember that and is only true if both sides are true. However, or is true if one of the sides evaluates to true. Okay, so now let's actually move on to writing our logic. So the first thing we're going to see is the if keyword. The if keyword takes a single expression inside of parentheses, which it will evaluate to be true or false. And if it evaluates to be true, whatever code we provide inside the curly braces, in this case a console.log statement, will be executed. So this console.log will only be executed, it will only be printed out if age is less than 18. If it is greater than 18, if it's equal to 18, we will not see this text printed out. So that's the first part. That's our bouncer checking if you are too young to get in. So next up, we're going to learn about else if. And the way that else if works is that it follows an if statement. It is a secondary condition. So in this case, we're checking if age is less than 18. So if someone is too young to enter the venue, if they're less than 18, they can't get in. The next thing to check, only after we check the first one, is are they older than 18 but less than 21? So else if works the exact same way as if, where we pass an expression in parentheses that will evaluate to be true or false. If it's true, the code inside the curly braces will be executed. If it is not true, if it's false, nothing happens. So again, else if works just like if except that it must follow an if statement. So we have this line here, age greater than 18 and age is less than 21, which is actually a little bit redundant. So think about this for a second, pause the video, and try to identify how we could refactor this. So this is a really minor change, but you'll notice I got rid of if age is greater than 18 right here and less than 21, and just turned it into else if age is less than 21. So again, just to reiterate, we had this before, and we refactored it into this. And the reason that we did it is it's redundant. The only way that this code is going to run is if this first if statement is false. So what that means is that this code here will only run if already we've established that age is not less than 18, or that it's greater than or equal to 18. So if you are greater than or equal to 18 and less than 21, you can enter, but you cannot drink. So the last step is the otherwise section, which is else. So else allows us to just have something else happen any other time. So in this case, if you are not less than 18 and you're not between 18 and 21, that means that you can come on in and you can drink. And so else does not take an expression in parentheses. It's different in that we just write else, and then whatever we put inside of curly braces will only be run as a last-ditch effort. So this will be run first, and if nothing is printed out, if this is not true, then we'll move on to this. If this is not true, then we'll move on to this. But remember, if along the way either of these is true, then everything stops and this else will not run. So if this if is true, this code is done. If this else if is false, but this is true, our else never runs. So remember, these are three different paths for one decision here. Okay, so your exercise here, there's a few of them, is to take the code that I just gave you with the bouncer for a concert venue and to add a few, let's say, quirky other conditions. So if age is negative, we want to make sure that we print an error message. If age is 21 exactly, we want to print happy 21st birthday, give them a free shot. And if age is odd, you should print your age is odd. So you'll have to do a little bit of math there to figure out if it's odd. And then the last one, which is a bonus, is to figure out if age is a perfect square. And if you don't remember what a perfect square is, you can look that up, but it's basically a number whose square root, the two factors are the exact same number. So 4 times 4 is 16, so 16 is a perfect square. 4 is a perfect square because 2 times 2 is 4. All right, so that's a super bonus. Have fun with this, and I'll see you in the next video.